API automation testing is a crucial aspect of modern software testing, ensuring that the backend services and applications interfaces work as expected. It involves verifying the functionality, performance, reliability, and security of application programming interfaces, APIs. APIs are used to enable communication between different software systems, and their correctness and performance are essential for the overall health of an application. Here's a detailed breakdown of what API automation testing comprises. 1. Understanding API testing. Objective: API testing ensures that the server's responses, output, are correct, and that the APIs function as expected when called by external systems. Components tested. Endpoints: API URLs where requests are sent. Request methods: HTTP methods like GET, POST, PUT, DELETE, etc., which represent actions to be performed on resources. Request payloads: data sent to the API in requests, e.g., JSON or XML. Responses: data returned by the API in response to requests, status codes, body content. Headers: metadata about requests and responses, e.g., content type, authorization. 2. Key elements of API automation testing. A. Types of API tests. Functional testing: verify that the API meets functional requirements. Ensure that inputs and outputs are correct and handle valid and invalid data appropriately. Performance testing: test the API's response times under different conditions. This includes load testing, high user loads, and stress testing, beyond normal user loads. Security testing: validate the API's security mechanisms, including authentication, authorization, data encryption, and data leakage prevention. This often involves penetration testing and ensuring the API follows OWASP security guidelines. Validation testing: ensure that APIs return correct data types, proper structure, and that validation rules are enforced, e.g., required fields, data formats. Integration testing: test how the API interacts with other services or systems. Verify that the integrations with databases, third-party services, and other APIs function correctly. Error handling testing: ensure that the API handles error scenarios gracefully and returns appropriate error messages and codes. Contract testing: ensure that the API adheres to predefined contract agreements, especially when multiple services or teams interact with the same API. Contract testing tools ensure that the APIs remain backward compatible during updates. Negative testing: check how the API responds to invalid inputs, malicious payloads, or incorrect usage scenarios, e.g., incorrect HTTP methods or malformed JSON. B. HTTP methods: get, retrieve data from the server. Post: send data to create a new resource on the server. Put: update or modify an existing resource on the server. Delete: remove a resource from the server. Patch: partially update an existing resource. Options: retrieve supported HTTP methods for the API endpoint. Head: similar to GET, but without the response body, used to check if a resource is available. C. Status codes: 2xx success, 200 OK, request was successful. 201 created, new resource successfully created. 204 no content, successful request with no content in response. 3xx redirection: 301 moved permanently, resource moved to a new URL. 304 not modified, resource not modified since last request. 4xx client error: 400 bad request, invalid input provided. 401 unauthorized, authentication needed. 403 forbidden, insufficient permissions. 404 not found, resource not found. 5xx server error: 500 internal server error, server-side error. 502 bad gateway, invalid response from another server. 503 service unavailable, server temporarily unavailable. D. Test data and payloads: request payloads, JSON or XML data sent with requests, for methods like POST and PUT. It's essential to validate the structure, data types, required fields, and ensure input data meets business logic. Dynamic data: use dynamic data or parameters for more robust testing, e.g., timestamp, auto-generated IDs, etc. Test data management: efficient management of test data across various environments is crucial. This could include external files, CSV, JSON, or databases. 3. API automation testing process. A. Planning and preparation: define the scope, identify which APIs need to be tested and the business-critical scenarios. Test scenarios: define the functional, security, and performance scenarios to be automated. Ensure full coverage of various input-output combinations. API documentation: review the API documentation, such as Swagger/OpenAPI specs, for endpoints, data models, and expected behavior. B. Choosing the right automation tools: there are various tools to automate API testing. Postman, primarily for manual API testing, but with Newman, Postman collections can be run via CI/CD pipelines for automation. REST Assured, a Java-based library for automating RESTful APIs. SOAP-UI, primarily for SOAP and REST API testing, supporting functional, security, and load testing. Karate, a BDD framework for API testing that supports easy-to-write scenarios. Tavern, a Python-based framework for RESTful API testing. JMeter, primarily for performance and load testing APIs. Catalan Studio, a codeless automation tool with API testing capabilities. CI/CD integration, ensure that the chosen tools integrate smoothly with CI/CD pipelines, e.g. Jenkins, Circle CI, GitLab CI, for continuous testing. C. Developing automated API tests, API test scripts, write scripts for different scenarios using the automation tools framework. Authentication scenarios, e.g., OAuth, API keys, JWT tokens. Functional flows, e.g., create resource, fetch resource, update resource. Data validation checks. Error handling scenarios, e.g., invalid inputs, invalid HTTP methods. Modularization, structure the tests modularly, e.g., shared libraries, common request builders, to avoid code duplication and increase maintainability. Assertions and validations, validate response status codes. Validate response body data structure and values, JSON schema validation. Verify headers, e.g., content type, authorization tokens. Check the timing and performance of responses. D. Mocking APIs, use API mocking tools, e.g. WireMock, mock server, to simulate API responses in cases where the actual API is not ready or external services are unavailable. Benefits, test integrations even when the third-party service is down. Isolate tests from external dependencies, ensuring more reliable results. 4. Continuous integration and continuous testing. A. Integrating API automation with CI/CD, CI/CD pipeline, integrate API test suites into CI/CD pipelines for continuous testing. Triggers, set up automated test runs on every code commit or at regular intervals, e.g., nightly builds. Parallel execution, ensure the tests can be run in parallel for faster feedback. Dockerization, use Docker containers for environment consistency when executing API tests. B. Test execution, execution frequency, API tests should be part of the regression suite and executed as frequently as needed, e.g., nightly builds, pre-release testing. Reporting, use built-in or third-party reporting tools, e.g., Allure, Extent Reports, for detailed test execution logs. Display response times, failed tests, errors, and success rates in dashboards. 5. API testing challenges. A. Versioning, APIs evolve over time, with new versions being released. Test automation must handle multiple API versions, ensuring backward compatibility while testing new versions. B. Dependency management, some APIs may rely on third-party services or databases. Ensure tests can handle these dependencies, either by using mocks or by managing test environments carefully. C. Handling flaky tests, API tests can sometimes produce inconsistent results due to factors like network instability or backend latency. To mitigate this, use retries on failing tests. Monitor for and address any test flakiness, tuning test timeouts where necessary. 6. Performance and load testing. API automation also includes testing how well the API performs under stress or heavy load. This is critical to ensure that the API remains functional and responsive under real-world conditions. A. Load testing, send a high volume of requests to an API and measure how it handles the load. Key metrics include response time, throughput, and resource consumption, CPU, memory. Tools, JMeter, Gatling, LoadRunner. B. Stress testing, push the API beyond its normal limits to test how it behaves under extreme conditions, e.g., high traffic, heavy database loads. Ensure that the API gracefully handles failures and doesn't crash unexpectedly. C. Scalability testing, evaluate how the API scales when the number of users or requests increases over time. This is crucial for ensuring that the API can handle production traffic growth. Conclusion. API automation testing plays an essential role in validating that the APIs function as expected and that they are reliable, secure, and performant under various conditions. The process comprises a broad range of testing types, from functional validation to performance and security testing, and is often integrated with CI/CD pipelines to ensure continuous delivery. By leveraging the right tools, setting up modular tests, and adhering to best practices, API automation ensures a stable backend and seamless communication between systems.